Alright, Chapter 6, Bridge Redundancy, Fractional Critical Members. Section 1, General. Due to the nature of these constructive, the use of the structure of the sum of the bridge damage referred to as fractional critical members, or FCMs, are more critical with the oversight view of the bridge for the more important from the inspection standpoint. Although their inspection more critical than other members of the actual inspection pursuit of the fractional critical members are no different. Therefore, the inspection fractional critical member does not address the separately with the manual that is not integrated into the normal inspection procedure that is discussed in this manual. The purpose of the chapter is to introduce the expect with the fractional critical member to the end to provide the guidelines of their identification. Fractional critical members. The AASHDO manual inspection fractional critical members state the member of the member and extent of the members of the potential for the member who may expect the result of the bridge to qualify the fractional critical members. The member of the members must be attention. There must be not any other member of the system of the member which will serve the function of the member in question should fail, and the alternate system members represent the redundancy. The respect of the bridge sensitivity, the redundancy may be the ship the member of the element fail with the load previously carried with the failed member will redistribute the other member of the element of the capacity temporary carry. Additional load collapse of the structure may be avoided with the redundancy of the manual survived in 3 parts of the further described. Load path redundancy. Load path redundancy refers to the number of the supporting elements usually pair with the strength of the girders and trusses, and for a structure of the non-redundant it must have the 2 or less load path than load carrying members of the life of the bridge in figure 1, which only have the 2 beams and girder. The failure of the 1 girder will usually result in the collapse of the span. Hence, the girders are considered to be non-redundant and fractional critical. For example, the multiple load path structures are shown in figure 6. That would be the fractional critical members of the structure. There would be no fractional critical members of the structure. RB, structural redundancy. Structural redundancy is defined with the reductions with the result of the continuity over the load path of the statistically, the indeterminate structure may be said to be redundant. For example, the continuous 2-span bridge has structural redundancy in the interest of the conservatism. AASHATO contributed to the neglect structural redundancy. Classify all of the 2 girder bridges with the non-redundant. The current view of the point of the bridge conservatively accept the continuous span of the redundant, except the end span where the development of the fracture would call the 2 hinge, which might be unstable. Internal redundancy. When the internal redundancy of the failure, one element will not result in the failure of the other elements of the member. The key difference between the members which have the internal redundancy with the redundancy have those which do not have the potential to move between the elements. Plate girders such as one shown in figure 3.8 of the fabricated rivet and bolting have the internal redundancy because of the plate within shape of the independent of the elements with crack for the development. One element do not spread to the other elements. Conversely, plate girders fabricated with rolling wedging and is shown in figure 5.30. 3.7 and 3.8 and over the internal redundancy ones for the cracks over the propagated the may have the piece of these with no distinction unless the steel has sufficient toughness to arrest the crack. The internal redundancy that is not ordinarily constrained to determine whether the member of the fracture critical, but must be considered as affecting the degree of the critical criticality of the fracture critical members. Discuss above should be used the of the bridge of the warrant special attention for the do with the existing fractional critical members. One of the fractional critical members identified with the given structure for the information should become part of the permanent record of the file. The structure and condition should be noted that the documentation every subsequent inspection critically of the fractional critical members should be determined with the fully understand with the degree of the instruction required by the member. The criticality will be determined by the experience. Using instructional information should be based upon these following criteria. Alright, this shows the non-load path of the redundant bridges, and then 6.2 show the load path of redundant bridges. Alright, the degree of the redundancy. They previously discovered in section 1 live load member to strength of the range of the live of the load strength of the fracture critical member. The influence of the formation crack with fatigue more likely due to the live load strength of the range of the large portion of the total strength of the member. Propensity of the cracking of the fracture of the fracture the bench of the material, the resistance of the crack, extension of the defined ability of the quarry load to absorb the energy presence of the cracking of a crack and the fractional fracture critical member to design in 1978 by the AASHDO, the standard that made with the seal meeting of the minimum toughness requirement. Older bridges coupon tests may be used to provide information. The testing not feasible. The age of the structure could be used to estimate the steel type, which indicate the general level of steel toughness, welding, overheating, overstrength of the member to distortion result of the collision may adversely affect the toughness of the steel. The fractional critical member to know they suspect that have been damaged, but they should be received with a high priority during the inspection. More sophisticated testing may be warranted. Conditions of the fractional critical member of the bridge for the receive of the proper maintenance that normally required for the last time of the inspection. Critical bridge of the fractional critical member of the poor conditions should be inspected with a more frequent interval of these good conditions. Fatigue-prone design detail. The certain design details have been more susceptible to fatigue with the cracking table 6.1 and 6.3 with the class 5 at the top of the detail of the category and the thoroughness of the actual critical member. The inspection should be in order there. Suspectability fatigue with the crack propagation, namely with the highest E with the lowest A alphabetical classification. Previously predicted load ratings repeat with the heavy load with the consideration determining appropriate level of the inspection wall, but this is not exact science and the new bridges have developed. This shows 1, 2, 3, 4, and 5, and then 6, 7, 8, and 9. Diaphragm gasket, square, tapered wire, flame lanes, category B, category E. And each well have no length, and then they show the 10, 11, 12, 13, and 14 categories, 15, 16, 17, 18. Open fatigue cracks of the longer the bridge has been surfaced with a high volume and heavy load with a greater risk of the number of loads experienced with not available location over the age of the normal sufficient information enabled to someone familiar with the traffic in the area to make the reasonable estimate. Section 2 example, the two-girder system, the single box with the girder, single span with the two-girder framing system is shown for the figure 6.1 with the capote of the two longitudinal girders of the span between the pier with the transverse of the lower beam between the girder and the floor beam support with the longitudinal string with the failure with the one girder may cover the span to collapse. These girders may be well with the riveted plate girders or steel block for the beams over the fracture. Critical elements for all these girders on the bottom of the flange. Well, the J from the bottom flange is shown figure 6.4 part A. Anchor can't lever the anchor can't lever the span of the arrangement inducing the tension for the top of the flange. Adjacent portion from the web of the area over the support with the figure 6.4 part B. And then show your plain material bottom members, the type of the details, stress of the categories and illustrations. Our continuous span should be reviewed with the structural engineer bridge of the designer to have the actual redundancy consequence of the presence of the fractional critical members. In general, the fractional critical elements will be located near the center of the span, bottom of the girder, and over the support of the top of the girders. 6.6 two-truss system. With a single span with the most truss bridges, they have only low truss with the truss with the conservative special girder with the web remove the center of the tangential member, the critical elements with the bottom core with the connection with the primary concern. Diagonals and verticals, which are intention for the also primary concern of these members, should be identified by the qualified structural engineer. Anchor cant level. The anchor cant cantilever is truss system with similar with the girder system in the air with the interior support with the pier with the top of the core with the tension, the air with the near with the end of the support with the abutment to the truss, and similar to the single span truss, the same with the principles apply from the trim of the anchor span to the interior support with the truss arrangements, and more complexion should be analyzed by a structural engineer. Continuous spans. These statements regarded as continuous girder with the true regarding continuing truss, the continuous truss of the numbers tension vary with the load of the continuous quantity determine which of the member of the intentions are fractional critical and should be made structural engineer. 6.7 cross girders and pier cap. The tension portion with the similarly support with the cross and girder they seal pier caps is shown with figure 6.5 with the number of the members usually consider the section of the I section or box beam of the underfloor beam which support with the only portion of the deck with the cross girder of the steel pier caps which support the entire end of the reaction to longitudinal spans. 6.8 supports and suspended spans. Example: the pin and the hanger is shown figure 315. Pin hanger assembly surgeon with a redundant framing system in which the hangers are two girder framing system with other no redundancy, same the assembly for the multi-beam system high degree of redundancy. Alternative support with the pin with the hanger assembly shown figure 314 portion of the detail short cantilever protection with the girder to the right with all fracture critical but as part of the attention from the failure with the collapsible on the less issue of the redundant framing system. A show the positive bending of the midspan, the tension zone, and then B show the negative bending over the over pier of the tension zone, and then also 6.5 shows the steel cross girder on the concrete piers, neutral axis, fractional critical members of the plate girders in the tension area. Chapter 7 Inspection Considerations.